להציג את קבלו עוז כץ, כפיים.
Thank you. I'm going to do the talk in English if that's okay.
Okay, no problem.
Okay. Can everyone hear me okay? Great. So things are not working as planned. I had a demo prepared, so it might be a very much a lightning talk because
Try to speak to the mic.
I will. So a small part of my presentation is the demo. That's not going to happen due to IT stuff. But I'll start with the talk anyway. So my talk is building the lake house of your dreams, which is kind of an explosive title. I will say, no spoilers. I will say that if you dream about lake houses, maybe this is a good time to take a small vacation. But regardless, let's see when we move to the lake house what our dreams should be. So I'm going to start with a bit of history. Or not. Okay. So once upon a time, we had a data warehouse. That's what we used to call it. It was on a physical box, right? Raise your hand if you ever physically touched your production database, like the server itself. Okay, a couple of old-timers. Most of you haven't. Okay, children. So once upon a time, this was life. We had a box in the rack. It ran a data warehouse. We scaled it up. We got a bigger box. And life was actually pretty decent because we had a database. It's not really a distributed system at this point. It's just a big database, which gave us a lot of pretty nice guarantees. So we had fancy things like transactions and constraints and snapshots and all these fancy features that allowed us to do resilient data engineering, let's call it. A transaction is a pretty powerful tool. But this is not the life that we have today. Now we have a lake house. So it's not a box anymore. It's a collection of boxes, each with its own role. So we have Amazon S3 or whatever equivalent object store you have from your cloud provider. That's going to be the storage layer. On top of that, there's kind of an ancient thing called Hadoop. You guys are children. You probably don't know it. And that's fine. You shouldn't. On top of that, raise your hand if you guys are using Spark. Any Spark users? OK, quite a few. And on top of that, that shiny new thing that turned our data lake into a lake house. And we call that Delta Lake. Some of you might call it Iceberg or Hoodie. A set of technologies that provide better guarantees than just throwing files into a file system and hoping for the best. So this is what typically the industry refers to as a lake house. But life is not that great on the lake house. So some of those guarantees that allowed us to build resilient systems before no longer exist, right? So it's really hard to do transactions because these are table formats and they only span one table, one statement. It's really hard to do any type of snapshotting, right? I want to revert back to a previous state if I mess something up. That's pretty hard to do, especially across tables. And it's really hard to enforce constraints. So I might have two different tables with a foreign key between them. How can I make sure that both these tables are in sync? Right? If I have a process that failed midway, I don't have a transaction, so I can't really guarantee that these tables are synced anymore. So this is kind of our life, right? If we're on a lake house, but there are better ways to do it. So one of the solutions to some of these problems is essentially to treat our data, to treat our tables and our data assets as an asset, right? So we treat code as an asset. We version it. We have processes in place to ensure that the code is of high quality. Let's do the same for data. So I'm working on a project called LakeFS, which attempts to do exactly that. The idea behind LakeFS is to essentially take that S3 bucket that we saw before, or whatever object store you're using, and treat it as if it was one giant Git repository. So imagine I could take my S3 bucket, hit a button or run an API call, and get a branch from that. And whatever happens on that branch stays on that branch, right? And the magic here is to do it without actually having to copy all the data, right? So it's very similar in concept to a database transaction, right? I have my own copy. I can do whatever mess I want on my branch. It's isolated. But I don't have to pay for actually copying all the data, not in terms of performance and not in terms of actual dollars. And once I have that notion of branching and merging back, I can actually enforce the same engineering practices that I have for my code, but for my data. right? So I create a branch, I do modifications to whatever data assets I have. I run tests. I can run quality tests. I can run referential integrity tests. I can do whatever testing I want to ensure the quality of the data. And only if these tests pass, I want to merge those changes into my main branch, right? And if human error occurs, and it does, I can simply roll back to the last known good state of the system, right? So very similar to Git. The power of this is to be able to do this across many petabytes of data, and that's what LakeFS does. So let's look at an example of what this looks like with our example of consistency. So let's say that that lower branch, that line at the bottom, that's our production branch, right? It could be master or main branch for the code equivalent. And I want to modify two tables, and I want to do them by keeping them both in sync. So a common example would be I have a table of raw events, and then I have the same events but partitioned by date or category or something else. And if I modify one view of that data, I want to also modify the other one. I don't want them to ever be out of sync. So what I can do with LakeFS is I can create a branch containing both these tables. I can modify table 1, modify table B, and then do validation. So I can use tools like Monte Carlo or Great Expectations or any other data quality tools that I'm using. But now they run on my own isolated branch. And I can even enforce that only if these tests actually pass, I'm able to merge those changes together into my data lake, right? And that merge is an atomic operation in LakeFS. So if I'm a data consumer, if I'm reading from that lower branch, either I see both tables in sync or I don't see any change. There's no like intermediate point in time where I see only like a half-baked solution or something that failed midway. Yeah, so this is the part where I was supposed to give you guys a demo. Due to IT issues, I can't. I'll be hanging around here later, so if you guys want to see the demo, I'll be happy to kind of show it on my computer. And that's pretty much it. So with LakeFS, you guys get all the benefits that you guys had on your existing data warehouse from back in the days, plus more, right? You get all the benefits of doing the actual versioning for the data, treating it as an asset, and essentially at the end, going back to building data products that we can actually trust because we validate them. So to learn more, feel free to check out lakefs.io. We're also on GitHub. Of course, we have a community on Slack. You guys are free to join. Thank you. Do we have time for questions? I'm not sure. I think we do. Any questions? Okay. Thank you.